In today's tutorial, we'll use RayTK to create a blobby shape that flows upwards, sort of like a stylized flame. This is inspired by a post on the derivative forum, which I've linked in the video description. I'll be using RayTK version 0.37, but most of this should also work in previous few releases in case you're using an older version of Touch Designer. Check the video description for a download link for the toolkit. I've also included a link to download the project file if you'd rather start with that instead of following along as we build it. The goal today is to make a kind of liquid blob that flows continuously upwards, occasionally splitting off little bits near the top like a flame. There are lots of different ways that we could achieve that result. I tried using a particle sop to instance and blend a bunch of spheres, but it ended up getting complicated dealing with the particles appearing and disappearing over time. So instead, I went with a simpler approach using noise to distort some shapes in a few different ways. So first, we'll create a base ellipsoid. Then we'll use a noise pattern to expand and contract its surface. Then we'll use another noise pattern to offset it in space. Then we'll taper off the surface as it gets past a certain height. Then we'll blend it with a sphere at the base, and finally we'll set up a material. Before we dive in, I'd like to thank all of you who support me on Patreon. It means a lot to me, and it helps push me to keep putting out more tutorials. So thank you to all of you. First, we need to add RayTK to the project, but a warning before you do that. At least in the current version of Touch Designer, dropping the toolkit into a project is going to stall for a while, sometimes up to a minute, and hopefully in future releases of Touch Designer, this is going to be improved, but for now, it is what it is. That stall also happens if you cut and paste the toolkit comp, so it's helpful to think about where you want to put it before you drag the tox file in. It will work wherever you put it, but I like to do that at the root, outside of the main project comp. When it's in the same network as the contents of your scene, the network editor is going to show a lot of these data connection lines, and I find that that can be kind of distracting visually, so I like to keep it in a separate component. So wherever you've decided that you want to put it, drag the toolkit tox into your project. Once you've built your scene, you can delete the toolkit comp from the project, which will also stall for a while, but after that, it's going to load the project a lot faster in the future, but you won't have access to things like the palette. So if necessary, pause the video while you wait for it to finish loading. Once the toolkit has finished loading and the editor starts responding again, navigate to where you're going to be building your scene, like the default Project 1 comp. First, we'll set up the renderer and camera. Open the RayTK palette with the Alt-R shortcut, and then type in RayMarch Render 3D and create one of those, and drop that into your network. And I'm going to change the resolution here to 1920 by 1080, but if you're on a non-commercial license, you'll need to keep it at 1280 by 720. Then create a null top connected to the first output so you can see the rendered image. With the renderer selected, open RayTK's Editor Tools menu with Alt-Shift-R. And then under Add Camera, we're going to choose Look at Camera. On the camera, let's increase the FOV angle to around 80, and then we can keep the default position of 005. Next, we'll define the SDF that will act as the basis for the rippling blobby parts. So open the palette again with Alt-R and create an ellipsoid SDF and connect that to the first input on the renderer. On the SDF, increase the Y scale to around 1. And then we can keep the X and the Z at 0.5. We're using an ellipsoid SDF instead of stretching a regular sphere because non-uniform scaling tends to cause rendering problems in ray marching. The ellipsoid SDF is specifically designed to behave correctly when it has different dimensions on each axis, though, so we don't have to worry about that as long as we're using this operator. Next, we'll use a noise field to expand and contract the surface with a randomized pattern. Open the palette again and create a round operator. And we're going to insert that after the ellipsoid SDF. So try changing the amount on that, and it's going to expand and contract the surface. So set that back to 0. So instead of just using a constant amount of expansion everywhere, we're going to use a noise field to vary it for different points in space. So create a noise field and make sure you're using noise field and not any of the other ones that are named similarly. And then connect that to the amount input on the round operator. Then drop the amplitude down to around 0.3 or so. And then increase the offset a little bit to maybe 0.2. And that's basically applying the same amount of expansion everywhere, so it's effectively the same thing as using the amount parameter on there. So now try moving different parts of the translate parameter on the noise field, and that's going to move that pattern across the shape. So you can move it side to side, up and down, but if you try to do anything on the z-axis, you're not going to see anything changing. And that's because the type of noise that we've selected here, that was selected by default, is 2D noise, meaning that it only pays attention to the x and the y axes. On the round operator, click the inspect parameter, and that's going to bring up this inspector tool window. There's a little bit of a UI bug in the latest version of Touch Designer, so you might need to click some of these buttons here to get those tabs to show up, and then switch to the preview tab if it isn't already selected. So in the window here, you can rotate it around, and you can see how on that z-axis, the pattern is kind of the same all the way across that. If you were only viewing this from the front, that might be okay, but it can be useful to have more flexibility with that, so being able to add rotation or move the camera around or so on. It's also just useful to have an additional axis that we can move things along. So let's close the inspector and go over to our noise field, and then change the noise type to one of the ones marked as 3D. So we can try simplex 3D, and now if we go to the Z part of the translate, you can see how it's moving the pattern there. You can also try some of the other ones if you want, but I think I'm going to go with the simplex 3D. And this type of noise is a pretty common one that has built-in support within Touch Designer. Noise fields are covered in more detail in a video in the RayTK intro series. If you want to learn more about that, check out that video. This gives us a decent blobby shape, and once we've animated the translation parameter, we can get it to flow in a particular direction. But it would be nice to have it warp things a bit more. So if you want, you could skip this part or disable it after adding it if you change your mind later. But let's try a different approach to adding some distortion to the shape. There are some limits to using the round operator the way that we are. So it doesn't really have a directionality to it. We can move the noise pattern in some direction, but it isn't really stretching or pushing in a particular direction. It's just kind of expanding or contracting the surface. So let's create a translate operator and insert that after the round. We're going to use a similar approach here using a noise pattern to drive the amount of translation, pushing it in various directions. So for this one, we're going to use a special type of noise called curl noise. Curl noise has some advantages, like producing vectors instead of a single value, like the other noise field. It also introduces some sharpness bits that I think make for a more interesting effect. It can be costly in terms of performance though, so if it slows things down too much, we're also going to try a cheaper alternative. To create a curl noise, and we're going to connect that to the second input, the translate input on the translate operator. So it may stall briefly while the shader compiles. So once that is up and running again, on the curl noise, increase all parts of the scale to around 3. That will spread out that pattern. You could also try using different scales for each axis if you want. So this controls the tightness of the pattern, but it's still applying the same range of displacement on all axes. With this much displacement, you're also going to see some places where the renderer gets a little bit confused and you get some kind of glitches. So bits in there that look like that. So try adjusting the amplitude to control the amount of displacement to get it to a more reasonable range. So again, though, this is applying the same to all of the axes. So it would be nice to be able to control the amount of displacement differently for each axis. So let's set that back to amplitude of 1. And then we're going to use another operator to scale the different parts of the values that this noise field produces. With the curl noise field selected, open the Editor Tools menu with Alt-Shift-R. And then choose Rescale Field. And then we're going to connect this rescale field to the translate. Noise field like curl noise and most of the types of noise in the regular noise field operator produce values ranging from -1 to +1. So on the rescale field, we'll change all parts of the input low to -1. Then let's set the X and the Z parts, the output high to 0, so we can just focus on the Y part. On the Y, let's drop the low part of that range down to maybe -0.3, and then bump up the high to maybe 1.4. So that way it is mostly pulling up with a little bit of a pull down. Now for the X and Z axes, we want to have a little bit of displacement, but we don't want it pushing to just one side or to the other. So we want to have those ranges centered on 0. So let's decrease the low part of the range to maybe -0.2. Do the same thing for Z. And then for the high, we go with +0.2. If you want, you could use an expression here to link the parameters if you want to make sure those ranges are always centered on 0. But it can also be useful to have the option to be able to make it go side to side if you want sometimes. So I'm just going to leave it as it is. Now let's go over to the curl noise field again and adjust the translate here. So let's go for the Y and we move that. We get that pattern moving upwards. And even if we are adjusting the X there, it's shifting the pattern, but it's not pushing the shape more along the X-axis. It's just changing where the noise pattern is that's driving it mostly upwards. We'll add some animation to this later on to get continuous movement. But for now, I'm just going to set this back to 0. When you are changing parameters like this, you may start to notice some performance issues. So if your frame rate drops too much while you're doing that, or if you just want to save on GPU resources for some other reason, there is a cheaper alternative that we can try. Curl noise can be especially costly, but there are some cheaper options in the regular noise field. So let's create a noise field. To then connect this noise field to the rescale field here, and you're going to get an error. That's because the rescale field is currently set to produce whatever the same type of value is that its input produces. So when its input is producing a vector, then it scales all the different parts of that vector and provides it to translate, and it's happy. But the noise field here is producing just a single number. So rescale field only applies the scaling to just that single number using that first part of those parameters there. And then it passes that single number over to translate, which doesn't really know what to do with just one number. So to fix this, on the rescale field, we can change the return type setting here to vector. So that is going to automatically convert a single number to a vector by just copying it to all the different parts of the vector if that input is a single number, or if the input is already a vector, it's just going to pass it along as it is. So we can easily swap between these two without having to change any settings on the rescale. There are actually a few types of noise in the regular noise field that do produce vectors, though, and those are the ones marked with deriv. So that means derivative, which is to say the slope of change of the noise in different axes. But those can be a little bit costly too, similar to curl noise. So we're just going to go with maybe Perlin 3D. And this type of noise, like most of the others, is producing that same -1 to +1 range, so we don't need to change anything on the rescale field there. But I like the effect that the curl noise produces, so I'm just going to go back to that one for now. But if you're having performance problems later in the scene, as you add more complexity to it, you can switch back to that regular noise field if you want. Next, we'll shrink the surface at the top to get it to fade out more up there. And we're going to do that with another round operator. So open the palette again and create a round. And we can insert that after the translate. Instead of using a noise field in this one, we're going to use a step field. So create a step field. Make sure you're using that, not any of the other ones with step in the name. Then connect that to the second input on the round. This field picks a point along a particular axis and produces one value on one side of it and another value on the other side. So let's change the axis here to Y. And then we want to switch on blending here. And then let's increase the blend range up maybe to around 2. That is the range starting from the edge position over which it transitions from one value to the other value. So it's using that low value for anything below that line and the high value for anything above it. So we actually want this high value to be lower than what it calls the low value. So let's drop that all the way down into a negative value, something like -0.5. So now we're keeping the bottom as it is, but the top is going to kind of shrink down so that you don't get like big bulging shapes up near there. Next, we'll add another shape at the bottom that kind of stays in place and blends with the blob that we've already created. So create a sphere SDF and then we're going to select both the round and the sphere and open the editor tools with Alt-Shift-R. And then we're going to go into Arrange SDFs, and we're using that and not Combine. And then under that, we're going to choose Smooth Union. And then on the arrange, let's switch on enable translate, and that's going to allow us to position each of the parts easily. Now let's connect the arrange up to the renderer. So it's a little bit hard to see right now because our sphere is pretty small. So let's increase the size on that to around 1. And then on the arrange, let's move on the translate parameters, the y-axis, we're going to move the blobby part up to maybe 0.8, and then we're going to move the sphere down a little bit to maybe negative 0.6. Then for the blend radius, let's increase that way up to maybe 1.4. Next, we'll add a material and a light instead of using the defaults that are built into the renderer. Select the renderer and open the editor tools menu with Alt-Shift-R. And then under Add Light, we're going to choose Point Light. Those may stall briefly while the shader recompiles, and then once it's done, let's go over to our light and change the position on it. So you can put it wherever you like, but I recommend putting it kind of back on the z-axis to maybe 3 or so, and then off to one side or the other. You can choose whichever you like to maybe 2 or so, and then up a bit to maybe something like 1. And now to add a material, let's create a modular mat. And we're going to insert that between the round and the renderer there. And don't worry if it goes dark, it's just because we haven't added any shading elements yet. So with the modular mat selected, open the editor tools again with Alt-Shift-R. And then under Add Diffuse, we're going to choose Orin IR. And we'll increase the roughness to maybe 1, albedo, let's say also to about 1. So that gives us kind of a base shading for the surface. To add some kind of shiny highlights, let's add some specular shading. So go back to select the modular mat, open the editor tools again with Alt-Shift-R, and then under Add Specular, I'm going to choose GGX. It'll stall a little bit while the shader compiles, and then on the specular contrib, dial in the settings to get it to look the way that you want. So I'm going to leave the roughness kind of maybe 0.6, up the for now a little bit, maybe also 0.6. So then on the 2 different shading elements, you can pick whatever colors you like. So for the diffuse, I'm going to go with kind of an orange. And then on the specular, I'm going to do kind of a pale green. That gives us that little bit of green and kind of the shiny highlight areas, and then that kind of dull orange in the rest. Next, let's add some animation. So we're going to do that by offsetting the noise patterns that are controlling the blob. Let's go over to the first noise field that's controlling the surface expansion. So select that operator and open the editor tools menu with Alt-Shift-R. Under animate with speed, we're going to choose translate, and we're going to use the top one there and not one of the individual parts. This will allow us to animate the individual parts on each axis if we want. So we can use the different parts of the speed there to control how much it's moving on each axis. And then we can use the speed multiplier to kind of scale everything. So I'm gonna drop it down to 0 or near 0 for x and z, and 1 on the y-axis. Then we're going to do the same thing over for the displacement. So go to whichever of the noise fields you're using, and we're going to select that, open the Editor Tools menu with Alt-Shift-R to animate speed. We're going to choose Translate. And then we're going to do the same thing on this speed generator. So dropping down the speed for x and z to near or mostly 0, and then 1 for the y-axis. And then you can adjust the speed overall with the slider. Then, if we want to be able to easily switch between those two, we can go to whichever one we just animated, right-click its translate parameter, choose copy parameter, go to the other one, right-click its translate, and say paste expressions. So now they will both have the same motion to them, so you can switch between them. Now I'm making a choice here to not use a RayTK switch operator, which would make switching between the two faster. And that's because that operator includes all of the code needed for both of the things that are connected to its input. And our goal here is to kind of reduce the amount of complexity, so I'm just hardwiring it in there. So it's going to be a little bit slow when switching between the two, but when it's just sitting there running, it's going to be faster. With all of that set up, we can now kind of dial in the settings to get it to look the way that we want. So I'm going to go over to the camera and kind of pull that back on the z-axis to get a wider view, maybe around 7. And then on the rescale field for the displacement with the translate, we can adjust the amount of displacement for each axis. So, maybe have it go in a particular direction, side to side, or just, increase the amount that it's flowing upwards or something like that. But you're going to notice if you push those settings to extremes, there are going to be some kind of glitches in the rendering. And yeah, if you like that, then you can just lean into it if you want. But if you want to avoid it, you're going to need to kind of keep a check on how far you push any of those parameters. Then same thing applies to the noise that's kind of expanding, contracting the surface. You can kind of bump up the amplitude if you want to have it more kind of spread out, but keep in mind that eventually you're going to get some kind of glitches and stuff in there that you may not want. So then on the step field that's controlling that tapering, you can use the edge there to kind of like pull down the point where it starts kind of like shrinking it down, or you can have it do that more abruptly. So kind of, if it's all the way down, then it's going to be just like a hard line, or you can spread it out more. And then you can change how much it shrinks at the top. So if you have it, really far down, then it's going to totally disappear up there. But if you keep it, not too low, then there will still occasionally be bits that will get up past there, which can be kind of a nice effect. And that's it for this scene. So to recap, we are starting with a tall ellipsoid. Then we are using a noise field to expand and contract that surface using a round operator. Then we are displacing it using curl noise or regular noise rescaled to a vector that's kind of offsetting position. Then we are tapering it off at the top to get it to kind of shrink down up there using a step field and round. Then we are merging that with a sphere to get that kind of solid base area. And finally, we are adding our material and rendering it out. There are lots of different steps that you could take with the scene from here. You could try out different noise patterns or other types of fields to control the displacement or the expansion. You could add some twisting around the y-axis or swap in some different kind of base SDFs or lots of different things. So I look forward to seeing what you all do with this one. If you post on social media, use the RayTK hashtag. And at least on Instagram, tag me to make sure that I see it if there's stuff that you want to show off. If you want to support RayTK development, check out my Patreon. You'll get early access to tutorials, exclusive scene downloads, and more. There's a link to do that in the video description. And even if you aren't able to offer paid support, you can follow me on there as a way to keep up to date on development of RayTK and tutorials that are coming out, including free access to a lot of the older content. Thanks for watching, and as always, make sure to like and subscribe.